Hi, recently I bought this carrier board for the nRF51 modules, and I wanted to dig up an old project of mine that used Bluetooth communication, a micro SD card and a sensor that logs temperature and pressure to the micro SD card. And what I wanted to do here is to add up something new to it. So we've got a SPI screen that logs and shows the graphs of the current values. So now let's drop the temperature a little bit, and we can see right here that the graph changes, and there's also a time to set for the logs. So to do this we will use a device with the nRF Connect application, something like this. So let's just quickly scan, and we got our device here, so let's connect. And I use the default Nordic UART service. So if we click here, we get the data that is being written to the micro SD card together with the time. So to change time I got two commands here. So it begins with H, and let's set it to, for example, 15, and for example, okay, something like this. Let's send it, and we can see the time changed, and the same is for the screen. And for the minutes, let's send something like M, and let's say, for example, 33. And something at the end. Let's send it, and we got the date changed. And the same is for the screen. So let's disconnect, and the device still works fine and logs the data. So in a moment I will show you how the logging works on the micro SD card. And one thing to mention here, that those modules are programmed by a J-Link. I got a J-Link right here, but if you don't have one, because they are quite expensive, instead you can buy a Nordic 52 board that already has a J-Link, and you can use those headers right here to connect to the serial wire debug and program the board. So let's get started with the project. So as you can see, I got the Segger Embedded Studio loaded up, so we will do the project in here. But first of all, let's take a look at the file that holds up the data from the sensor. So this one, and I created a Excel file, and we will drop the data right here. And from this we can create some graphs. So this is the temperature measurement overnight, and this is the pressure measurement. So from the 22 to 6 morning, something like that. So there are no hangups, everything is being registered. We got all the continuity here. Okay, so first of all, how to make the project running. So let's go to the SDK. So in order to do something with the project, to compile it and so on, you need a Nordic nRF5 SDK in the version of 12.3.0, and you can download this from the Nordic site. I will link this in the description. So as we got this in examples, BLE peripheral, I added my example, which is the SPI screen. So right here I got the files for the display, for the micro SD card, and those are my libraries, so I don't use any Nordic libraries here. Okay, and right here we got for the sub-device S130 the project in the Segger Embedded Studio. So this is the project file. As you open this, you will get this window pop up, and so let's quickly take a look what we got here. So the program starts. We set up a few pins, so mostly chip selects, the SPI. So as we got the SPI running, we can set up the display. So this is the usual function that I use in my library. And next on I deselect, make sure that I got deselected the display, and set up the micro SD card here. And after this, we need to draw the bitmap. So the microcontroller has a little bit of low RAM because it got only 16 kilobytes, and it won't hold up the whole picture here. So we got to do a trick here, and we gonna read pixel by pixel. So we read a pixel, we set up the location of the pixel on the screen, we create the pixel from the micro SD card data, and we put it onto the display. So pixel after pixel, the whole screen. Okay, so as we got this done, we initialized the timers. So this is used for setting up the ADC. So we grab the measurements at a regular rate. So on the top of the file, there's a define of the time interval. So 2 seconds, because this is in milliseconds. And this triggers a function right here. So we set up the ADC, grab the data, and set up the flag that we can now send the data. After that, I also configured the watchdog, because if you got the microcontroller hung up, you can also restart it through the watchdog. Next on the 2-wire interface and the regular for the Bluetooth, so this section here, and this is just for toggling the status LED. Some debug information. We enable the watchdog. We test the micro SD card again. And after this, we got the main loop of the program. So toggling the LED, status LED, feeding the watchdog. And as we got the flag from the timer, so we got the ADC measurement completed, we can grab the data from the temperature pressure sensor. You can have the version with humidity, so that would be a additional lines of code that you have to put in. And as you got measurements here completed, calculated, we got a function here, display update. So we simply print the data and we draw 2 bars, 2 graphs actually, and they are made in a way they are done through a sinus function here, so it looks like something like a rainbow or something, and it is using the maximum and minimum of the measurement to locate the bar in the right position. And also a feature, if you got the temperature over 30 degrees, the font is being set to red. If not, it's white. So something like this. So the temperature data first, and next on the pressure. Okay, so as we got the screen done, we can also right here I create a string to print on the screen that tells the actual time. And if we got a connection available for the Bluetooth, we can send the measurements right here through the default Nordic UART service. Okay, and at the end, right here we can write the measurements that we got, and they are stored in this variable. And the last thing here is to zero the flag. And here we got a function that is used to schedule the Bluetooth communication. Okay, and the last thing here is how do we set up the time through the Bluetooth. So let me get the function here. Oh, as you can see, I already got the humidity calculation here. So if you would have a different sensor, you can use this code. Okay, and now to the function that sets the time. Okay, so we got here a handler for the data from the Nordic UART service. So if we got a message that's longer than 3 and the first charter is H, we grab the 2 bytes of data and calculate the hours. So for example, 6 in the morning would be 06, and plus something to have the exact length over 3, and else we search for the first charter M, and just like here, so for example 610, so it would be 10 in ASCII. And this is how you set up the time. So pretty much simple. So maybe let's add something here. So for example, let's set up the fonts on the screen to something bluish instead of white. So right here we would like to change this to something like 100, this to 0, and let's copy this and set it right here. Okay, save, and now let's build it. So after we got this built, let's connect to the J-Link, and first of all you have to erase everything. And what you can do, you can just select download BLE project. So this downloads the sub-device that's used for the Bluetooth and also the program. So now let's take a look how this works on the screen. I'm plugging in the power. And it slowly draws the wallpaper. And we got the text color changed. So we raise up the temperature a little bit, and we can see that the temperature bar changes here. For the pressure, it would require to lower the sensor a few meters and then bring it back up to see a change. But it all works. So I hope you find it useful. Those nRF51 chips are extremely cheap and they are great for those kind of applications that you need to just measure something, set up it through Bluetooth, or manage it through a Bluetooth central. So just absolutely great. You only need to know how to set them up. So for example in the Segger Embedded, but if you get going with them, they are really great. So hope you find it useful in your projects and see you in the next one.